Kia ora koutou. In this video I'm going to review trigonometry and I'm going to go pretty slowly with this one. So we're going to look at how we label the sides, and then we're just going to find sine theta, cos theta and tan theta for a bunch of problems. And again, I'm using Dr. Austin Maths worksheets for the questions because they are so beautifully laid out. So first of all, let's just remember what's going on when we do trigonometry. So this is a revision video. So if you're watching this and you're in year 10, this is probably not the best place to start, but hopefully if you're in my year 11 class, it will help you remember what we did last year. So again, we're working with right angle triangles when we're in year 11. Next year, we'll move on to looking at what we can do when we don't have a right angle in the triangle, but we're going to label it differently. And for the first problems that we're going to do, we're going to be given an angle. And so we're going to have an angle marked on the diagram, and everything is going to be relative to that angle. For example, if we're told that this is angle theta, which we write like this, then we start by trying to label these three sides. We need to find the opposite side, and we need to find the hypotenuse, and we need to find the adjacent. Okay, so the way that I always do it is I start with the angle and I treat that like a little eye, and that's looking out here, and that side there is the opposite side, and I'm going to label that O. The long side of the triangle is the hypotenuse, so we label that H, and the side next to or adjacent to that angle we label A. So we're going to do that whenever we're working with a problem where we've got an angle and we know a side length. So it's quite a different structure to the problems we were doing with Pythagoras in the last video that I made. So let's just go through a bunch of triangles where we've got a right angle triangle and we've got an angle. Here's my angle theta. So I look out here, and this side is going to be my opposite side. This side here is going to be my hypotenuse, the long side, and this one here is the adjacent, so it's next to the angle. I'll just do a couple more. This time I'm going to put some made up angle numbers in. So if this angle is 23 degrees, then looking over to here, this side is the opposite, the long side is the hypotenuse, and the adjacent is A. And notice that I'm always using this notation of O, A, and H, right up here, O, A, and H. And then we need to remember that there are three ways that we can link up pairs of sides with the angles. So just putting in a triangle in here, and we'll give it a little right angle. Suppose that this length here is 32 degrees. And this side length is the opposite, this side length is the hypotenuse, and this side length is the adjacent. Well, trigonometry is all about the patterns between different pairs of sides. And we have three what we call trigonometric ratios that we're going to start off with: sine theta, cos theta, and tan of theta. And they link up different pairs of side lengths. Okay, and if when we're in class, I'll wave my arms around lots, and we'll look at how, as this angle changes, what happens to the relationship between this length and this length, or between this one and this one, or between, which one haven't I done? This one and this one. So that's O and H, O and A, and then the last pair that we'll look at between this side and this side. Okay, so first of all, when we look at the length, let's take some of these colours off. We've got too many colours here. Most of you probably already know this, that where I'm going with this is so katoa. Okay, so here's my opposite side, and here's my hypotenuse. And we call the link between those two sine of theta, right? So it looks like sin of theta, but it actually means sine, and it's the sine of the angle. And that means that we take the opposite length and divide it by the hypotenuse. Next, we find the cosine of an angle. So cosine of theta is where I'm linking up the adjacent side with the hypotenuse. So that we write that as cos of theta, and that's equal to A over H. And the last one is where I'm linking up the two sides that are not the hypotenuse. So I'm linking up the opposite and the adjacent. So when I'm linking those ones, we call that the tangent of the angle. We call that just tan theta, and that's O over A. And the way that we remember this is that we say sine of theta is sine, opposite, hypotenuse, opposite, hypotenuse. Cosine, C, is adjacent over hypotenuse. And lastly, tan of theta, T, is the opposite over the adjacent. Okay, and so you'll hear me say so katoa lots and lots of times in class, because it's just a shorthand way to remember that when we've got a trig problem, what we do first is that we label, and then we choose which situation we're working with. But in this video, all we're going to do is just go over how to do those ratios. So I've got a bunch of examples coming up now. So 1, 2, 3, and then we go to number, I don't know why we go to number 5. We'll fix that up. Let's make that number 4. And then I've got a couple of harder examples where we're going to have to link up what we did with Pythagoras. And they're all from Dr. Austin Maths. So in example 1, the sides have already been labelled for you here, right? We're given O, A, and H. And the angle here is x. So sine of x is equal to the opposite over the hypotenuse. So sine of x is going to be equal to 4 over 5. Cos of x is the adjacent over the hypotenuse, so it's going to be 3 over 5. And tan of x is the opposite over the adjacent, so it's going to be 4 over 3. Okay, and we're going to get really used to doing that. So we're always going to have a fraction for sine, cos, and tan of an angle. Let's move on to the next one. So pause the video and first do the labelling here, and then work out what each trig ratio is. Okay, so labelling, here's x. So this side is the opposite. 13 is the hypotenuse, and 12 is the adjacent. So sine of x is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. So we can very easily pull those numbers into the fractions. So sine of x will be 5 over 13. Cos of x will be 12 over 13. Let me just write that out a bit better here. So 12 over 13, 5 over 13. And then tan of x will be the opposite over the adjacent. So it's going to be 5 over 12. Right, example 3. Now this time we're getting more realistic numbers. We've got decimals, but I'm just going to leave those as fractions for this video, because all we're trying to do here is remember how we do our labelling, and then we work out the ratios. Okay, so here's my angle. The 5.5 side is the opposite. That means that the 4.8 side is the adjacent, and the hypotenuse is 7.3. So sine of x opposite over hypotenuse will be 5.5 over 7.3. Cos of x will be 4.8 over 7.3, and tan of x will be 5.5 over 4.8. So in all of these so far, the only tricky bit is doing the labelling, and that should be starting to feel easy. Okay, let's go on to example 4. Now at this time, we've got a square root in here, And I just want you getting used to these for year 11 because we will come across them more. And you can see that that square root makes sense if you think back to what we did with Pythagoras, right? Because here we've got 2 squared and here we've got 5 squared. So they're the two short sides. And 2 squared plus 5 squared gives me 4 plus 25, which is 29. So that's the long side squared, c squared. So the long side will be the square root of that. In this example, those 3 numbers have still been given to you, but in the 2 harder ones, we're going to have to work those out. So again, we start with our angle, we look across, and this is the opposite side. The 2 centimeters is the adjacent side, and the square root of 29 is the hypotenuse side. Sometimes that square root of 29 will be written with a square root sign, and that means it's what we call an exact value, but sometimes it'll be a decimal approximation. It'll say 5 point blah, blah, blah. Right, so in here, sine of x is equal to, again, we're doing so katoa, so sine of x is equal to 5 over the square root of 29. And I'm just going to leave it like that. Cos of x is equal to 2 over the square root of 29. And tan of x is equal to 5 over 2. I'll simplify that one to 2.5. So I could go on and simplify those to be decimals, but I'm not going to do that in this video. All I want you doing here is remembering, how do I find sine, cos, and tan? Okay, we've got 3 minutes until the video runs out, so 2 harder examples. In this one here, sorry guys, I'm still getting over the bug. We don't have anything here. We've got an angle here, so we can do our labeling, but we don't seem to have any numbers, which is a bit odd. So here's O, here's A, and this side is the hypotenuse. So let's look at what we've been given. Well, we've got nothing going on here or here, but for tan of x, we've got 9.9 over 2. So we know that that must be the opposite side over the adjacent side. So that means that O is equal to 9.9 and A is equal to 2. So we can write those onto my triangle. And that means that I can use Pythagoras' theorem to figure out h, right? Because we know that a squared plus b squared is c squared. So 9.9 squared plus 2 squared gets me 102. So that means that c squared is 102. So c is equal to the square root of 102. Or I could say that it's equal to 10.1 to 1 dp. I'm going to leave that in this case as the square root of 102 to get you used to working with exact values. Okay, and not all of the class has to be confident with that, but if you're going on to level 2 maths, it's a good thing to be not freaked out by surd signs. So here, sine of x, we have opposite over hypotenuse, and then for cos of x, we have opposite, adjacent over hypotenuse. So this one will be 9.9 over the square root of 102, and cos of x will be 2 over the square root of 102. I really don't like how messy those two are, so I'm just going to write those out underneath, and I'll give myself a bit more room. Okay, so sine of x will be 9.9 over the square root of 102. And that's gone. It's still too messy. That's better. 9.9 over the square root of 102. And cos of x will be the adjacent 2 over the square root of 102. And you can see that that fits in with what we had for tan, where the O was 9.9 and the A was 2. And we found h using Pythagoras. So h was equal to the square root of 102. One more to do like that. You can try this one. Okay, running out of time, so I've just paused the video and done that one for you. You can use Pythagoras to get the short side, and then you can find cos and tan. Thanks for watching. More tomorrow.